Good evening or good morning, depending upon which time zone you're in. So I'm going to give a little bit of a review because I've been working in this area for more than 30 years and talk about the nighttime light imagery. We've already discussed many of these topics before, but I hope to offer a new insight and perspective, and in particular concerning the 50 years that we now have pretty close to of nighttime imaging from the DMSP, about a project that I've been working with 𝗖cieः𝘁𝗨𝘀, formerly of the NOAA NIEC, on the digitization of analog film over a 20-year time period, and then talk about some of the aspects, particularly to do with the spectral aspects of what is being missed with the day-night band, then show some work that has been published on carbon dioxide emission and economic development, and finally land up quoting Christopher's paper about opportunities and challenges. So the first thing to say is that what does it actually represent, these nighttime lights? If you look at the land surface temperature field of this area around Chicago and the Great Lakes in North America, what dominates this area, aside from the city of Chicago, are physical geographical features like the rivers, what you cannot really see on most of the cities. But the second you actually switch your view onto the DMSP composite radiance, then obviously you can see the individual urban developments. So there is no direct relationship between the temperature patterns apart from when you have urban heat island effects, and certainly in other areas of this thermal infrared image temperature record, you have no relationship at all to the urban scenes. So lighting accounts for around 20% of the total electrical energy consumption, which is directly itself linked to carbon dioxide emission, according to reports from 2015. And the per capita consumption of light is around 0.7% of gross domestic product. Now, as we've already seen from a number of previous talks, the lighting has changed dramatically across Europe and North America with a shift to these LED lights from fluorescent and high pressure sodium. I'll come back to that a little later on. Unfortunately, something that hasn't been mentioned so far is there is also a side effect of light intensity increasing, particularly in the blue. Now, nighttime light on several different publications has been linked both to sleep deprivation in urban areas and has documented impacts on human health, particularly concerned with autoimmune responses such as cancer, as well as natural impacts on natural flora and fauna. Now, the DMSP radiance calibrated imagery, the first official Block 5D system flew in 1972. I managed to get hold of some images from 1971, but I can't find anything from 1960s. And the optical line scanner had a particular kind of scanning geometry in order to obtain these nighttime imagery to try and maintain a fixed spatial resolution across the field of view, which has been carried on with the day-night band. Now, the initial nighttime light data analysis was according to the frequency of occurrence over the compositing time period as a percentage of the whole time period. And radiance calibrated data only really became available in the early part of 1996 and for limited areas again in 2000. Now, these annual digital composites, which have been used by a couple of different authors, presenters earlier, and the variable gain control is used to acquire the images, with high gain being used to amplify the signal from faint light sources which saturate data from big cities, compositing from two different variable gains. Now, this shows the first nighttime light image I've yet found and that Chris has found, which shows the UK down the left-hand area, and also shows the Edinburgh-Glasgow region, and you can see you get lots and lots of saturation. There's also a small portion of an aurora. Now, these DMSP nighttime images were really only acquired for the purposes of looking at nighttime lights when there's a less than a quarter of a moon. So they're not acquired for a large fraction of the time. And the kind of light sources, and I'll come back to this in a moment, is on the order of nanowatts per square meter per steradian per micron. Now, 11 million of these film strips, and shown on the right-hand side is a rather wonderful example of the whole of North America being cloud-free, and you're seeing a magnificent aurora. There are about 11 million film strips which were selected out of about 42 million, which are lodged in the Denver Federal Records Center, and which were going to be destroyed, but fortunately we've managed to rescue them for another 50 years. Now, the DMSP spacecraft, the other thing that needs to be borne in mind is that they have different nominal local times of the node, equator crossing node, which vary substantially from one F series DMSP Block 5D to another. And therefore, compositing data which come from different DMSP satellites can cause all sorts of problems when you're actually trying to use them in a quantitative fashion. Now, shown on the left is a composite, the first one that's produced by Woody Sullivan III, who I believe is still at the University of Washington, at least he was 3 years ago when I last had some email exchange. And on the right is one of the first second generation nighttime light using, in this particular case, digital data. The first one was used from analog data. So all those digitized film products are now available at my lab, and as a courtesy from 𝗖cie and Kim Bao. So looking now at a time sequence, here shown is an annual time sequence from each individual DMSP F satellite, and you can see that one of the most obvious things is the South Atlantic anomaly, which as no one has mentioned so far, which rather dominates this region off the coast of Argentina and Brazil. And you can also see that you do have, in some cases, even though you try and suppress it, aurora. And you also have, even with a composite taken over a year, you still get some regions which have persistent cloudiness, where the cloudiness is not properly removed. So given the fact that you have this level of variability, and even though there are these stable light sources, it's still quite challenging to be able to use this individual data without doing some filtering. Now, we've already heard about the fact that nighttime lights can be used as a political indicator. There's a rather excellent example in Korea, as well as the squid fishing offshore. But there are quite obvious economic and political components which I want to explore in a moment. The first one relates using an aggregation at the country scale. This was published in Ambio in 2000 of the nighttime light frequency in that particular case, looking at the total lit area as a percentage of each country. And apart from a few countries that didn't seem to quite report the true situation that are shown as outliers here, this did manage to obtain global relationships at the country level between GDP and carbon dioxide emissions, which was then applied to actually produce a map. The map at the top is the map that's produced solely from DMSP nighttime lights from the time periods I mentioned earlier with the radius calibrated data. And the map at the bottom is produced from the carbon dioxide inventory. I can't remember, I know it must be Archive Center in Tennessee. And in fact, there's very, very good correlation between the two, which is described further in that paper. Now, going back to an earlier point, when we started looking at DMSP data, we were rather surprised when we had NUTS level 3, which is a rather obscure EU Eurostat's measure of population decided on a country-by-country basis, and it's different size for each country. But when we actually look at this NUTS level data, and we look at the former Federal Republic and the former German so-called Democratic Republic, East Germany, we can see very substantial differences between these two. And this is also possible to use this data in a country where we have very disaggregated lighting, like the Netherlands, to actually look at different economic sectors between agriculture, industry, and services, and therefore be able to determine what is the strength of each of those. That would be very interesting to do now, obviously, with the City of London and various other financial areas which are no longer switching on their lights in the evening. Now, using those relationships for each individual country, and we did this also for the United States, we could produce a gross regional product map, which had an accuracy of greater than 80%, and which very clearly shows the dominant impact of urban centers like Paris, Barcelona, Madrid, Milano, Torino, and various other Italian cities, and also the Ruhrgebiet in Germany and various other cities in the Benelux countries. Now, coming back to VIRS and what does street light represent, here you can see a spectral responsivity function in the gray of the DN day-night band, and in particular I'd like to highlight the LED street lights, this green area which shows this very strong peak in the blue, which, as I said, is related to various disturbing health impacts. And you can also see how this peaks around the green to red, and how this is very different to fluorescent lighting, and also very different to the high pressure 𝗖𝘁 that we saw earlier. Now, the VIRS instrument was first flown, of course, on the 𝗖𝘁 NOAA Polar platform, which was launched at the end of 2011, and including the visible infrared radiometer. And that, of course, is an update to the DMSP operational line scan system, having had quite a lot of input from the designers of the previous system. And SNEP began systematic production in January of 2012, and you can obtain all of these. And it appears that Black Marble products, when I looked yesterday and could find this information relatively quickly, only since 2017. And now, of course, we have NOAA 20, and there are also NOAA products which appear to be being produced in parallel. So I'd like to talk for a moment about the actual range. Now, this particular camera uses a technique called HDR, which allows you to take multiple images at different gain states. And you want to be able to cover the entire range, going all the way from the aurora down here at nanowatts, all the way up to sunlit clouds and land and sea ice, which are in the milliwatt regions. So we've done an analysis, and the paper is currently in review, and looked at air glow, which is down at the 5 nanowatt level, all the way down up to sunlit clouds over snow and ice. HDR operates very well apart from extremely dynamic phenomena such as aurora, because you get very strong artifacts, and lightning being another case in point. Now, when we actually come to look at the full-scale resolution, you can see here one of the most interesting aspects is that the VIRS shows individual villages near Delhi in India, which are all merged together and smeared out in the DMSP product. And we can also use the change in lightning, which was also shown by an earlier author, here for looking at areas where you have pink or mauve, you have reduction, and areas in cyan where you have increase. And one of the things that you can see very obviously here, and the first presenter showed an example of this region here, is the substantial reduction as a direct result of the Civil War. But one point that hasn't really come out so far is the fact that the nighttime light data, and in particular the nighttime light data of a country like China, is very different depending upon whether you use the DMSP, not just because of a 2.7 kilometer resolution, but also because of the much better MTF that you have with the VIIRS day-night band. And just to point out on the way is that there is spectral information available. M8, M7, M8 and M10 bands all show nighttime light features. So, but of course, those are not necessarily the ones that you would choose in order to look at different sources of night. But just to make this point, that if you do try to continue time series between DMSP and VIIRS, you will run into problems for these reasons. Now, looking at what, and this of course is one of the reasons why we're attending this workshop today, it's partly to hear from our colleagues at Albert Orbital about what they have planned, is we can see that as a function of spatial resolution and time, that the DMSP has given us essentially the core data set for the order of more than 40 years. And we can see the Argentinian 𝗖cie and also the ISS astronauts that I'll discuss in a bit more detail in a second. You can also see where the VIIRS day-night band sits. And now we have a series of instruments, both from Aerospace Corporation in Los Angeles through to systems developed at LISMARS in Wuhan. And we can see that we're having increasing spatial resolution in order to be able to look at much more of these detailed aspects, which is one of the things we desperately need. Now, if we take a look at, for example, Sentinel-2, this is a seasonal composite produced at 20 meters. We can see that urban areas are almost invisible. It's a grey mush, as I call it. We can see certain areas in London, like we can see the reservoirs which are close to Heathrow Airport, which these days, of course, have most of their lights switched off. And we can also see some of the development of the City of London in this region here. But as soon as we look at the International Space Station at around a resolution of 50 meters, and one of the problems that I found is looking at the ISS, almost all of them either don't have proper forward motion compensation or are blurred because of atmospheric effects. So the quality of a great proportion of that ISS archive is, I think, fairly limited. But here you can see, as a piece of history, we had a small portion of our orbital ringway, or beltway, as it's called in the US, which was lit. And then 10 years later, almost the whole of it is lit. There's just a few small sections left where it's not lit. And this is the best resolution image, which I estimate to be around 30 meters ground separation distance. But again, it's still pretty blurred. So we need something which is much more rock solid. And this brings us to the fact that one of the advantages, however, of having astronauts, and this is from Chris's work, is that the astronaut can keep clicking away and looking at that particular city for quite a few minutes as the ISS passes overhead, so you can actually see the changes. And so it would be very nice if we had some kind of monitoring global system, and I don't think that having something at L2 to balance the Discover Epic at L1 would be appropriate. You wouldn't get the resolution. But if you had a constellation, perhaps a CubeSat, that were actually snapping away every 5 minutes, you would be able to look at the temporal variability. So in conclusion, and taking it directly from Chris, we have a variety, and I've only clearly indicated a few of these, in atmospheric sciences, in ecology, in energy, in epidemiology, which we really didn't get into, and in light pollution. But I think that obviously light pollution and socioeconomics seem to me to be two of the most fruitful areas, but also in the case of looking at CO2 emissions and seeing how well countries are actually complying with the Paris Accords. Thank you.